Here we have DNA. We have the hydrogen bonds holding the two strands together, and we have the phosphodiester bonds holding the nucleotides together. DNA needs to replicate, so to begin, we need an origin of replication. We'll say right here. At this origin is where replication begins. But to begin, the double helix has to be unwound. An enzyme known as helicase, here, unwinds the DNA like this and breaks the H bonds holding them together. Now, as you can see, the DNA wants to wind back up. And so to prevent that, we have single-stranded binding proteins, which bind to the unwound DNA and prevent it from winding back up again. We also need gyrase. Gyrase will reduce the torsional strain, the tension, in the rest of the DNA due to this unwound part. RNA primase will bind to the DNA and synthesize RNA primers where replication can begin. DNA polymerase III binds to the primers added by RNA primase at the 3' end and will then synthesize DNA in the 5' to 3' direction. So this one will move in this direction like so, following the unwinding. This is the leading strand. Now this one on the other strand, because this one is going 3' to 5' this way, synthesizes DNA in the opposite way, going this way. And because it has to wait for this to unwind but still go this way, it's making discontinuous little fragments of DNA. These fragments of DNA are known as Okazaki fragments. So now replication has occurred, and mind you, anything happening over here is also occurring over here, except that on this side is the leading strand, and this is the lagging strand. Now, DNA polymerase I will cut out any of those RNA primers placed by the RNA primase and replace them, and replace RNA nucleotides with DNA nucleotides. And lastly, since there's these small gaps between the Okazaki fragments, we have ligase, which goes over them and seals these gaps, these nicks in the DNA, and makes the phosphodiester bonds holding them together. Then replication is complete, and we now have 2 new strands of DNA